Alright, as requested, this is a little video on just a recap of hyperbolas and the things you've got to be looking out for when doing anything with hyperbolas, whether they be looking at the domain and range or the asymptotes or the sketching or anything like that. What this video is going to be is just a quick run through of all the main things you need to know. So the main things we're going to be covering today are, first of all, basically like the step-by-step process you need to do here. So we're going to be talking about the asymptotes, the general shape of the hyperbolas, and just a few like graphing techniques as well. So what I'm talking about here is, first of all, with your hyperbolas, you should the first thing you obviously need to know is we're talking about a function where we have some numerator, but that numerator is just going to have just some numbers in there for now. I mean, you can have more difficult hyperbolas, but this is for the interest of 2 unit. So we're just looking at just some number on the top with some thing on the bottom as well. Generally, it's going to be some linear expression, so maybe like x, or could be like x plus 2 or x minus 8 or whatever. Basically, we're going to have the numerator with something on the top and some x on the bottom. And what we're going to be talking about here is, what happens and how we can sketch and the general features of these hyperbolas. So first of all, I've just got this example from the textbook, and this is a kind of good demonstration of why these hyperbolas look the way they do. So looking at this, we want to sketch y equals 1 over x. So if we were just to do a table of values, what we can see here is, obviously straight away, if I make x equals 0, we know that we can't divide by 0. So what we should say is we want to sketch it, but x can't equal 0. That's worth noting, right? And that's going to be a key thing once we get into a few other hyperbolas. You first of all want to realize, well, what can't x be? What is the restriction on our domain? Once we've done that, if we were to put that into our table of values, we see that when we're looking at what happens when x equals 0, that's not a minus sign. That's basically saying it doesn't happen. All right? So what we're seeing here is that there's an asymptote going through there. That's kind of like an imaginary line that your graph, your curve, is getting very close to, and it gets closer and closer and closer and closer, but never actually touches. From there, if you were to plot in a few other points, say like x equals 1, alright, if we were to plot in x equals 1, you'd just be having 1 over 1, which just equals 1, so we're just plotting that point in there. If I was plotting in making x equal 2, we'll just get a half, which kind of looks about there. If I made x equal 3, we see that this number is getting smaller and smaller and smaller. So and if our x values are smaller than 1 but bigger than 0, so we see, for instance, a half, if I did 1 divided by a half, that would actually equal 2. It gets bigger. And when you think about it, that makes sense. I mean, if I had an orange and I cut it into halves, I'd have 2 halves. That's how, when you're dividing by a fraction, it gives you a bigger number. Anyway, so as you see here, that happens with all the positive values. As x gets smaller, the y values get bigger, but as the x values get bigger, the y values get smaller. So that's why you're starting to see this steep at the start kind of shape, but as x gets bigger, it gets flatter and flatter and flatter. But the one thing that doesn't happen is it won't equal 0. If you made x equal 2 billion, if you did 1 divided by 2 billion in your calculator, it's still going to give you some very, very small number. It'll be like 0.0000000 something or other, okay? It's not going to equal a negative number. It's not going to equal 0. Your calculator might say it's 0, but that's because your calculator's kind of given up and said, yeah, it's close to 0. Alright? It's not going to be exactly 0. And the same thing happens, I'm not going to get into too much detail, but the same thing happens on the negative side. So we see it kind of creates a mirror image going through there. But that's all really good, but you're not going to have time to do a table of values like that. And even then, you might miss the key components. So that's what I want to focus more in this session. So basically, if I was to create a step-by-step guide for looking at your hyperbolas, you first of all want to think about the shape, okay? And by the shape, I mean it's either going to be, like if I have my two asymptotes, and I'll talk about them in a second. If you have a positive fraction, so basically there's no negative signs in front of your x or in front of your fraction or whatever, it's going to be in the top right side and the bottom left side. But if I had a negative fraction, so that means there might be like a negative sign in front of the fraction, or maybe there might be a negative number in the numerator or something like that, it's going to be on the other two sides. And I'm not going to go into too much detail as to why. I guess the only way that I could say that is do a table of values with a negative one. If you want to try yourself, do a table of values for negative 1 over x. And as you do your table of values and start plotting your points, you're going to see it's going to go on the top left side and the bottom right side. So the first thing you want to do is think about the shape and like the regions. The next thing you want to do is find the vertical asymptote. And what you're looking for there is, okay, what can x not be? Okay, so in that example I've written in the top right there, the only number that x can't be is 0. So that means you're going to have a vertical asymptote going through 0. I'm just going to do the list now and I'll show you an example in a second. The next thing is you want to look at your horizontal asymptote. For now, at this early stage of t-unit, let's just assume that it's always going to be a horizontal line going through 0. The reason why that's the case is the only way a fraction can equal 0, which is what we'll show, like, you know, when it equals 0, the only way a fraction can equal 0 is if the numerator equals 0. But we just talked about how the numerator is going to be some other number. So for instance, looking at that one on the top right, we're saying that the numerator is negative 1. If the numerator is negative 1, that means it can never be 0. That means it can never equal 0, so a horizontal asymptote is, you know, going to be a horizontal line going through 0. And then lastly, the one last thing you need to do is just find another point. So find another point. And what I'll suggest you do with that is look at maybe the y-intercept if you can, or plot in any other point. The reason why we do that is to get a sense of scale. We need one number on our x-axis and on our y-axis. So even though you might have your asymptotes, you want to have just one point somewhere, just so you know how big your hyperbola is and make sure it's in scope. So let's look at this for an example. We have 3 over x minus 2. So the first thing we want to ask ourselves is, what's its shape? Well, it's a positive fraction because the numerator is positive, the coefficient of x is positive, there's no negative sitting out front or anything. Yes, there is a negative in front of the 2, but that has no effect on the fraction itself. So that means straight away we should be thinking it looks something like that. Alright? Might not look exactly like that, but again, you want to be thinking about it straight away. You want to look at your function and think, okay, what does it look like? Next is we want to find the vertical asymptote. Okay? The vertical asymptote is we need to think of, okay, what can x not be? Well, we can't divide by 0, right? So that means the only value of x we can't do is if the denominator equals 0. So if I made x equal 2, that means I'll be doing 2 minus 2, which equals 0. I'll be doing 3 divided by 0, which is not a very nice thing. So that means we're going to say that x equals 2 is going to be our vertical asymptote. Another way of saying it is that basically x can't equal 2. If x can't equal 2, that means the line x equals 2, that vertical line going through 2, would be your vertical asymptote. And then, again, let's just assume that the horizontal asymptote is going to be at y equals 0. Just for now, assume that that's the case. So we have that. The one last thing I need to do is also find another point. I suggest you find the y-intercept. So let's go ahead and find the y-intercept. As we know, to find the y-intercept, we make x equals 0. So we have 3 over 0 minus 2, which is just negative 2. So that means your y-intercept is going to be 3 over negative 2, or I guess we could say negative 1.5 as well. Alright, so now we have all the information we need to sketch this. We know there's going to be a dotted line going through 2, for your vertical asymptote, you're going to have a horizontal line going through 0 for your horizontal asymptote, and your y-intercept is going to be negative 1.5. So let's just put that all information together. So we have a y-axis, an x-axis. So first of all, if that we want to put our point in, so our asymptote in. So if that's 2, we're going to put a dotted line going through there. All right. That dotted line is kindly saying you cannot cross this line. This hyperbola is not crossing this line. It's not part of the function itself, but it's good for us to draw it there, just to tell the HSC marker, or whoever's looking at your work, or just yourself, what it can't be. And our horizontal asymptote is going to be just along the x-axis, so I just do a dotted line just above it, just so it's just sitting on top. Now the one last thing is I want to put my y-intercept in there. So if this is negative 1, maybe that's negative 2, so that means my curve is going to go through there. And other than that, we know it's going to be at the top right and the bottom left. So from there, you don't really need too much more detail than that. Just draw the basic hyperbola shape. And you want to make it as symmetrical as possible. And there you go, there's your graph. As we see, what I could do if I wanted to be a bit more precise is plot a few more points and just see what happens. But that's fair enough. I mean, all I need is 1 point and it's fairly accurate. We're not looking for absolute laser accuracy. We're looking for the shape, just testing your knowledge of what a hyperbola looks like and its key features. So that's that. I'll just do one other one. So here's a negative fraction this time. I'm going to go through this one a bit faster. So again, this is a negative fraction because it has that negative sitting at the front. That means it's going to be looking like that this time. It's going to be in those two quadrants. The next thing we'll want to do is we'll say that x can't equal negative 1. So that means our vertical asymptote is going to go through x equals 1, negative 1, sorry. And our horizontal asymptote is going to go through y equals 0. Again, just assuming that that's the case. And then let's just find one other point. Let's find the y-intercept. We'll find the y-intercept to be at negative 2 because we're just making x equals 0. So now that we have that, we have a few points and our verticals and horizontal asymptotes. Let's go ahead and sketch it. Alright, so we've got this, and this. Vertical asymptote, that's going through negative 1. Horizontal asymptote is going through 0. Should probably label my axes. And so the other point is I need to make sure that my y-intercept is also there. So if that's my negative 1, that'll be negative 2. And then going through maybe something like that. Okay? Making sure it looks nice and symmetrical. So something like that. And again, the reason why I know it's in those two regions is looking at that. Because there's a negative fraction, that means it's going to be in the top left and the bottom right. I found my vertical asymptote, I found my horizontal asymptote, I found one other point. That gives me enough scope and enough information for me to draw my hyperbola. Anyway, hopefully this has been helpful, and do give me any feedback you can on this, whether it's helpful, what you want me to do better in the future or whatever. All feedback is much appreciated. Thank you.